It's 10 a.m. and time to get coding. Understanding what a developer and lead developer do is that they're the same. In this case, we have a development environment, which can be very personalized, but in general, I prefer a two-monitor setup. In one monitor, I have my integrated development environment, which is the means by which I can write code in a standard way with common tools so I can run and build the application out of it instead of having to resort to the command line. And then in my second monitor, I have all the secondary stuff. I have a web browser, which is important for email, accessing your application if it's web-based, and Googling stuff. Additionally, since we're remote most of the time these days, we're going to have some sort of messaging technology to stay in contact with our team, whether Slack, Teams, or something else. And finally, we're going to have a shell, or the command line, which is sometimes easier to be able to troubleshoot and diagnose things with when I can just resort to the command line and run commands instead of having to go through the IDE, especially if I'm troubleshooting something build related. As the lead developer, I'm usually going to be working on something more complicated, more broad, or something that someone else just wasn't able to handle. And so in my case, when I'm looking at what I'm doing, I'm getting back into coding, I usually start with what's the goal? What am I doing? And that's going to involve our work tracking system, where the work that any given developer is going to be quantified into a work item, or in the Agile space called a story. In my opinion at least, every story should contain two things. A description about what it's doing in a given when-then format, in this case for doing an Okta-based login. Given that I'm a corporate user with a corporate email address, when I type in my corporate email address and press the button to log in, I'm directed to some sort of Okta screen where I have to enter in my credentials and select a second source of verification, like an authorization app on my phone or having to enter in a code that was texted to my phone. That's the scenario. Sometimes that's enough. I also like to have acceptance criteria, which tell me when the work is done. Not quite task level, but in this case, I know that in order to do this work, there's an existing Okta setup for which I have outstanding questions on. I have to integrate with something existing. I know that it works with corporate emails, and I know that we want to leave the current customer flow unchanged. And then in the case of these corporate emails, I want to use multi-factor authentication, which is an internal detail of the Okta setup, but still something I want to note. There's going to be a secondary form of authentication for doing the corporate login. However, yesterday I had asked security in the security channel, hey, I found the instructions for creating a new Okta tenant. I followed those. I created a help request. The response was supposed to be within 8 hours. Nobody responded. It's 10 a.m., so I go ahead and decide to escalate this myself. I find the person who manages the channel and send a message to him and say, hey, I opened this request yesterday. What's the status? I need this in order to continue my work. While I'm waiting for an answer on that, I try to see how far I can get without knowing or having Okta to be able to work with. So I open up my diagramming tool of choice and I start to draw out how this is going to work just from a general Okta standpoint. However, a couple minutes into it, I get the dreaded instant message for a lead dev of hi. I jokingly say this because when someone says hi, they're expecting an immediate response. There's an expectation there. And my other opinion is that instant messaging is really meant to be asynchronous, meaning I'm not expected to drop everything I'm doing to answer a question. And so when I see something like hi, I either ignore it until I have time to talk to them, or I say, hey, what's up? So I had that message. I get back to what I'm doing. I start drawing my diagram. So I go and I pull the Okta documentation, and I realize that in terms of the Okta login, it's going to be a client-only chain. So we're using a web-based integration. We're going to have to use this Okta library, which is then going to interact with this Okta API in order to display the secondary authentication mechanism. In this case, we're just going to redirect them to an Okta web page. They're going to enter in their credentials, and then they're going to be redirected back to our web application. However, because we have an existing security mechanism, I know that just because I logged in with Okta and I get this Okta token back, that's not enough. I'm going to have to authenticate with the rest of my system. And so the plan is that I want to take that Okta session token and I want to call a new endpoint for login in our backend and use that to establish a new session. So that's the overall plan for how this work's going to happen. and I've divided it up into front end and back end. Oh, another interruption though. At 10:45 a.m., I get a message from the manager saying, hey, that Okta thing, it was already set up. I'm sorry. We forgot to notify you, but here's a link to the details. So I'm good to go. I know it needs to change. I know I have an outstanding question from Dev 2 I'm going to get to at some point. And now I have my Okta tenant set up so I can go forward with the work. So when dealing with a third-party integration, it could be very important to prove out that integration. So in the case of integrating with this new Okta service, I know from a UI perspective that I'm going to have to redirect the user to a new page, and then I'm going to get a token, and I'm going to use that token to somehow do a login. Before I start making permanent changes to the application, I'm just going to go ahead and do what I call temporary coding. I'm going to do a partial coding implementation to just locally redirect my corporate email address to the Okta page and then redirect back to a blank page. The whole purpose is I want to make sure that I fully understand how the integration works, but also I want to verify that I'm able to get the token I expect via their own documentation, which will then become what I'm going to use to prove out the backend. So I bring up the web app on my right, I do a login, note some of the tests that are going to change when I do this work from a customer and employee perspective. Customer is unchanged, employee is going to change, and I verify that I'm able to redirect back into our application with the right Okta token. So now that I've proved out that in general I know how the front end's going to work, it's time to get a little bit more specific. This becomes a more architecture activity, but I know how login normally works. The UI calls the login on the back end, it looks up the user in the database and returns a session token. Okta's going to work a bit differently. In this case, I know that the UI is going to have to redirect to an Okta website where they're going to actually do the login. Then they're going to get redirected back with this Okta token. So that's step one. It doesn't involve our backend yet or our database. And so the plan here is rather than trying to make all this happen to the same login endpoint, the intention is to write a new endpoint that gets the Okta token, verifies the authenticity of that Okta token with Okta itself. So I can say this is the right token, and there's some built-in checks to make sure, for example, that yes, this was the token, yes, it was issued, and I can pull out the username, and then under the assumption that Okta returned the right data, I can then look up that user in the database and then return the session token. So architecturally, I want to draw this out and attach it to where the rest of our diagrams are, maybe in the story, but this is going to be the basis by which I'm going to tackle this work, and if I were helping someone else out, I would provide them with these same types of diagrams explaining the end-to-end flow.